Hey everyone. I've been asked quite often how exactly I'm doing my reverse engineering and which tools I'm using. Quite often I just have to explain those things. And what I thought would be much more easy if I create a blog post and maybe record a kind of a short tutorial to kind of, show what I'm doing. And this is exactly the subject of this video. So I've written a blog post on my website, which is reverse engineering VM setup and how to set up VM for reverse engineering on Windows. Now you can find it on my website if you go to blogs, and this has like a detailed description of what to do and which tools I'm using. Now it might change in the future, but for now I'll just give a quick overview of what I'm using. Now I'll be going pretty quickly over each tool, so if you're interested about specific tool, I will put time codes in the description so you can actually see what I'm doing. Well, first of all, I have to point out that all of my reverse engineering work I always do in a VM. And this is important because, obviously you can mess things up. You can mess up your operating system, or in case you're reverse engineering malware, there are additional restrictions that have to apply. And that is why I always do it in a VM. Another benefit of doing it in a VM would be that you can use something which is called snapshots. For instance, here in VMware, you can actually go back in time to whatever snapshot that you saved before, which is very, very valuable, not only for reverse engineering, but also for development. Now, this blog post is not about reverse engineering malware specifically, but in case you are reverse engineering malware, make sure that you disable network adapter, or at least have like some very secure VPN connected to it. Don't just connect it to your regular home router. And also make sure that you follow such precautions as do not share networks between guest VMs and the host, disable clipboard sharing, maybe don't even enable drag and drop between guest and host. Definitely ensure that you install updates for the VM software to prevent things such as VM escape by malware, and so forth. So again, this post is not about reverse engineering malware, it's just general advice. Okay, so which VM software I'm recommending? I'm personally using VMware Workstation Pro. I think I have version 16. This is what I'm recording on right now, and this is what you see in the background. This is really nice. I have to point out that it's paid, you have to pay for the license, but the good thing is that this is one-time payment, so that it doesn't come with a subscription to the at the moment of this recording. I personally like a few features, a few UI features, and also how stable it is and how many operating systems it supports, and also how easy it is to set up a guest operating system. Now, keep in mind that there are also alternatives like VirtualBox from Oracle. Now, VirtualBox is absolutely free. It's multi-platform. It works pretty much on most platforms. And for instance, I was using it on a macOS, which was really nice, and I definitely recommend it, especially as a free solution. Now, VirtualBox for me is not the best solution because it is a little bit clunky to set up, and sometimes things don't really work well in the UI. Now, additionally, if you are on a Mac, and especially if you need to reverse engineer or work on Apple Silicon, like M1 or M2 chips or whatever is the current one, or ARM architecture, you will need a special VM for a Mac. In my case, I'm using Parallels, and it works really well not only to run ARM version of Windows on an ARM macOS, but also to run macOS on macOS for ARM architecture. Now, unfortunately for Parallels, this is also a paid solution, so you have to pay. The good thing is that this is one-time payment at the moment. So that would be my recommendations for the VM. Again, VM is very important because you'll be working a lot in it. That is why make sure to set it up and pick something that will be very handy for you. In my book, it is always nice to have a paid solution because you know that they will maintain and develop it, and you can always get answers to your questions from the support. Okay, now speaking of the guest operating system, In my case, I'm using Windows 10, and yeah, this is Windows 10 Pro. This is just, you can download it from the web. Make sure to get a legitimate version. Don't download just some, you know, something from the torrent site. Microsoft provides links for you to download it. I'll update my blog post so you can actually go there. And for me personally, Windows 10 Pro seems to be kind of like a middle of the line. Now, as of today, obviously in the future this may change. It also depends on specific requirements of the software. Sometimes the software that you are reverse engineering might require, let's say, server type OS or newer like Windows 11. In that case, as you can see, I have them here on the sidebar, so I have quite a few versions of OS installed. Now, in case you don't care about bloatware, you can actually download, install Windows so-called N OEM, and this blog post describes that it basically doesn't have as much bloatware. Additionally, when you install a guest operating system, make sure to disable automatic updates, which is very important. And the reason being is that you don't want to leave your operating system, your guest OS, in the middle of reverse engineering and then come back and see that the operating system restarted itself. This is very annoying. So I wrote a blog post how to do it. Now, really simple, a few steps. You just follow and do it in the GP edit, and it won't auto-update. Now, you have to update it once in a while in case of some vulnerability, but do it manually. Now, as for the license for Windows, if you have OEM license, obviously use it. Sometimes company provide license for you. Now, if you're just an independent freelancer, if you don't register or activate your Windows 10, it will continue working. It won't let you do a few things with the UI, but overall, it should not limit your reverse engineering work. Okay, so next would be your native disassembler, debugger, and decompiler. Now, this works. The native part means that this software, debugger or decompiler or disassembler, works with code which executes directly on CPU. That's what native means. Also down here, I kind of explain the differences between disassembler, debugger, and decompiler. So please make sure to read it. I'm not going to review it. Also, really good and important distinction between live debugging and static analysis tools. These are kind of like two major differences between them. Okay, and now the tools. Unfortunately, I don't have one specific tool that can kind of do everything, and I mean debugging tool that can do everything for me. That is why I have to use a group of tools. In my case, I have them right here on the desktop. I'm using Ghidra, I'm using IDA, and I'm using XDBG. So let me show you real quick about every single one. Now, Ghidra is a static disassembler and decompiler. Now, in recent releases, it also claims to have a live user mode debugger. Unfortunately, it's really buggy, and at this point, I would not use it as a live debugger. But it's really handy as a static disassembler and decompiler. Now, the upside about Ghidra is that this is free and you don't have to pay any license, and you can install it on as many machines as possible. Now, the downside is that Ghidra is very resource intensive. Well, it's written in Java also, which is not the best thing ever. And well, there are a few things that people don't like. For instance, that it's been developed and maintained by a 3-letter government agency in the US. For me, I have no problems with it. Okay, guys, Ghidra has a little bit quirky installation, so let me show this real quick how you can do this. Now, unlike other software on this list, Ghidra doesn't come with MSI or any kind of installer. This probably is because it's written in Java, so you obviously have to have Java installed, and also it's cross-platform, so maybe that's why. Now, to install it, you go to GitHub, and you download this large file, which is not that large, to be honest with you. But before you can run it, you actually need to install it. to install Java. Now this is kind of like the most annoying thing. Now on the first page that I went through, if you scroll down, there's an installation guide. Now if you have Java already installed, and note this is Java, not JavaScript, you don't need to do anything. Now Java comes from Sun Microsystems, I believe, and there's some kind of license involved. So if you click on installation guide, if you click on minimum requirements, and over here on the software, you have a few options for Java. I personally would pick this Amazon Corretto, whatever that is. And then when you go to that page, it will show you, it will be an Amazon page. And then I personally downloaded 64-bit version, JDK, this one. So then when you download it and go into your downloads and install it, this will be just a short installation of Java. Now after that, when you have your Java installed, to install Ghidra, like I showed, you go to GitHub, you download this zip file, and what happens is that inside that zip file, you will have a folder. It's basically a large zip folder, which would be this Ghidra version public. So, and inside of it are Ghidra files. So what I did, which is kind of like unusual, because Ghidra doesn't use registry or any kinds of Windows specific ways to store its database, I put it into my documents folder to make it writable by Ghidra, otherwise it may complain. So then when you unzip everything, what you need to run is this Ghidra run file. Me personally, I created a shortcut and gave it a nice icon, so I know that this is Ghidra. Okay, and this is how you install it. Now to run Ghidra, you basically start that shortcut that I showed you. And now the problem with Ghidra is that this is really, really slow. You have to have really nice hardware and have a lot of memory to be able to run it comfortably. And also its UI is somewhat clunky, and because again it doesn't follow UI principles. So for instance, let me show you real quick how would you reverse engineer a binary file. So at first when you start it up, it will show you this window. First thing you need to do, you need to create a project. I'm assuming most will be non-shared ones that you will create locally. Now, ideally, what Ghidra wants you to do is to create a project for every single app that you are reverse engineering. In my view, it's not very convenient because I'm not sharing it with anyone. I just have it here in this VM, so that is why I kind of put everything in one project. This might not be the best idea, but this is again what really works for me. Now, as you can see, the path that it wants to save to is not really Windows friendly, so I personally put it into Documents, and I create a new folder which I call Ghidra, and I select it, and my project, I just call it reverse engineering. Okay, so now the project is ready for you to actually start adding things to it. For me, the easiest way, well, let me just show you with this example, the easiest way to add something to your project for reverse engineering is to just drag it here. And Ghidra will show a couple windows. Well, right here you can see that this is a 32-bit executable, and it's a native portable executable file. Okay, and this is where the slowness of Ghidra comes in. Obviously, if you have really high, high-end CPU, and maybe don't run it in VM, it will run faster. In my case, like, it always has to do something like this, and it takes time. As you can see over here, it takes a lot of CPU resources, and it's already eating up a lot of RAM. So let me hold it, and well, I guess it just did it by itself. Okay, the first thing that pops up that kind of like always throws me off is that Java, or something that, well, I guess, yeah, Amazon wants to have access to your firewall. Again, kind of creepy stuff. I didn't allow it before and things didn't work, so you have to allow it. I know this part is kind of annoying. And UI is also pretty weird because you see it doesn't fit into my window, but it basically gives you an overview of the file that you're just dragged into it. Okay, at this point you would think like, oh yeah, it's ready to go, and now what? Well, at this point you have to actually double click this thing to begin your static analysis. And at this point I believe Ghidra should open up. Now it says that the file was not analyzed. Would you like to analyze it? Make sure that you say yes, because otherwise it will be pretty difficult to work with. And when you click yes, it will give you this hardly understandable window. I'm not sure exactly what some of these are. You can technically, select all of it and play with it. But again, this is not the tutorial about using Ghidra. I might record one later. So at this point, I'll just click Analyze. And another confusing thing about Ghidra, you might think, and now what? Well, the first thing I always do, I expand it to the full window. And look at the bottom right. As you can see, it's doing its Ghidra business here. I'm assuming it's downloading or analyzing something. Now, even though I saw in the documentation that you can begin analyzing and working with it now before this whole shebang is over, in practice, it is not very usable. Things would be very slow and it wouldn't run well. So what I usually do when I open a new project, I just let it do its thing. It usually takes like from a few minutes to like 10 minutes if it's a large file. So just basically sit tight and just wait for it to go through. Let me pause the video and I'll start over when it's done. Okay, well, maybe a minute or a couple later, as you can see at the bottom right here, everything has finished. And also, as you can see in the window here on the right, I have symbols loaded. Before we do anything, let me adjust the screen real quick so that I can actually see a little bit. So if we go into settings, look for the font. And I want to set this one to 16. Okay, so as you can see, again, I'm not going to go over through all the features of Ghidra, but basically it has multiple windows. This one on the right has sections in the PE file. I usually close it because it's just useless in this case. Now, the section on the right is kind of helpful because it has like all the functions that were found in the symbols. In this case, I don't have symbols. That's why it's just like system functions pretty much. They're grouped by letter. So if you like, let's say, open them up and you can actually see the function and when you click on it. Now, two main windows would be assembly window on the left and decompiler window on the right. Now also important things like back, for instance, so you can go back and forward. And also if you want to see or correlate decompiled code to machine code, if you click on something, the code on the right, you see this call right here actually translates to this security init cookie function. So it's kind of helpful. Again, if you click on something on the left, the disassembly window shows you what exactly was used for this decompiled version. To switch to it, you can double click, and windows are kind of customizable. So as you can see, you can kind of read. Again, this is pseudo C, so don't expect it to compile, but with some squinting you can kind of tell what's going on. So in this case, if you scroll down and if you know how Microsoft CRT works, you can tell that this is the actual main, and you can rename it. Let's say you can say Win main. And obviously as you work, you can save your project, so make sure to do this. It won't autosave. And yeah, so because this is MFC, you can see by presence of AFX, so that's why it just goes into this depth of MFC. Okay, and this is pretty much how you work with Ghidra. Again, this is not a full tutorial, obviously, and you can get, if I have time, I'll show you how you use Ghidra. And the reason I'm not a big fan of Ghidra for everything is because of this kind of stuff. You see, like if you look at decompiled code, like what most people use Ghidra for, it is very confusing. Now, sure enough, this is probably valid, legit C, but as you can see, the disassembly is much more readable. So that is why this part is not something I would recommend anyone using. Obviously, it has to go in conjunction with the disassembly and also with the decompiled version. Okay, so this is Ghidra. Let me close it up, and obviously I want to save my okay, well, that's what I want to do. Okay, now you see the problem of Ghidra just in front of you. Okay, next one would be WinDbg. Again, this is quite useful debugger, and it comes in many flavors. This is one of the oldest debuggers, I would say, in the bunch, and this is also something that is maintained by Microsoft and most certainly used by them not only to debug Windows but also to debug Microsoft apps. Many people like older version of WinDbg. I personally prefer this new one, which in my view is better. It just looks better. It has many bugs ironed out, so I definitely use it. Now, to install it, again, it's pretty easy. It comes in an app bundle. You can just download here and it will install it locally. Now, WinDbg is something that I personally use mostly for crash log or crash dump analysis. I'll show it a little bit further down this tutorial, and also for kernel debugging. Kernel debugging seems to be the only available through WinDbg, and it is very powerful. So again, this is WinDbg. There's not much to tell you. Again, there's a lot of tutorials how to use WinDbg and its power. Again, I'll refer back to it in a little bit. The third one that I wanted to show you is a third-party debugger, which is X64DBG. It also used to come with X32DBG flavor, but right now you just have one. Now, it's open source. You can download it from this file, or from this, from this website. And it also doesn't require installation. You just have to drag it into, well, in my case, in the documents folder, I believe. Yep. So, and then when you get here, you click this X96DBG and it will install everything. And after that, go into each of these corresponding folders and you can create shortcuts, or it can actually create it for you. Now, X64DBG is a native debugger, which is really nice, and it works very similar to other debuggers, which I will show later. It has a few quirks, like this one, for instance. You see, like when I'm trying to debug something, it doesn't tell me anything. Well, the reason being is that, well, it has to be an exact match for the bitness of the app. So these kinds of little things kind of like don't make me want to use it that much. But again, many people like it. It's free, it's open source. Unfortunately, it's Windows only. I'm not a big fan of its UI, to be honest with you. It has some clunky things here, but overall it's just like, like any native debuggers, so it's usable. Again, this tutorial is not about X64DBG, but this is how you install and use it. So let me close it. The final one that is definitely not my favorite, but it's really popular and many people are using it, and I'm talking about IDA. Now, IDA comes in two major flavors. One is the free one, which obviously is free, you don't have to pay for it, and the second one is a pro one. Now, the pro version is, it has Decompiler, kind of like similar to what Ghidra has, and it has other features. Unfortunately, for the pro version, is that this is very, very expensive, and you have to pay yearly subscription for it. So unless you are working for some, company that can pay that subscription for you, I would not recommend buying a Pro version. Additionally, it's also very slow and it is quite buggy. So definitely not my favorite, but because IDA is quite popular, I usually use it for my tutorials. Now to use IDA, let me just demo it really quick once you install it. Unlike x64dbg, it comes with just one binary, one icon. So to open your binary for debugging, you just drag it into it. It shows you some basic information about it, so you know it's a 64-bit native file. You open it up. Now, then it will ask you about symbols. In my case, no, I don't have it. And yeah, so as you can see, it starts downloading something. Again, somewhat slow, so you basically at first have to sit and wait. It's not really long, but once it goes through, you will see a window for the WinMain. Well, let me just wait a little bit to see if that happens quickly. Okay, so here's the WinMain. So at this point, you can install breakpoints. You can do all kinds of things. Now, in my case, I always try to set up a debugging commands right here so that you can actually, step through. For instance, when you run your executable, because this toolbar is not available originally, and it also helps for recording, I kind of prefer to click buttons on the screen instead of doing the keyboard. Again, this is my personal preference. But again, I usually do this, and then I also go and save desktop, save as default, so I don't have to do this again. Okay, this tutorial is not about IDA, but this is how you set up and use it. Let me get out of here. I don't need to save anything. Okay, so these are my recommended debuggers for native world. Now keep in mind that there are others that I did not mention here. Obviously, it's kind of like everyone's preference, and again, they exist, but again, this is what I'm using. Now, a big distinction in Windows is between two types of executables. One would be native executables, like I was demoing before. And the second class, the newer class, would be managed or .NET executables. This is very important for reverse engineer to determine which executable you are working with and use the appropriate tools. Now, in my view, the debugging tools for .NET or managed executables are somewhat limited, but one of the best ones that is available today is dnSpy. Now, dnSpy has been discontinued by its original creator, and what exists now is a fork of dnSpy, so-called dnSpyEx, that I'm using. Now, installation is really simple. You just download the release, I think it's like right here, and then you unzip it somewhere in the program files. And after that, you use two flavors, 32 and 64-bit, to actually debug your .NET executables. Now, obviously, this project is open source, which is really nice, which kind of helps. Right now, let me demo real quick how you use them. As you can see, I have two shortcuts, and you just do it yourself after you install them. So let me demo a 64-bit version, because I have a 64-bit operating system. So when dnSpy starts up, it can let you do many things, very similar to what you were able to do with Visual Studio. In this case, one of the ways how you can use it is to attach to a running .NET executable. Now, in this case, there's something called Phone Experience Host from Windows. So when you do exact same attaching to it as you would do with Visual Studio, so it kind of like attaches to it. As you can see, the process is running, and if you want to, you can, for instance, pause it or break into it. And as you can see, you are inside that phone experience host. And then you can do pretty much what you would do with many other executables. You can step through it. Well, in this case, Yeah, I don't think you can do it. Let me double check. Yeah, again, because the executable is not my own, but obviously you should be able to do all this stuff. Now, to give you a little bit better example, let me download something that I'm familiar with. That is actually .NET executable. So if you go into my website and download FTPS transfer, this file is a .NET binary, and that would be really nice to demo for dnSpy. So if we take both files and create a test folder. Okay, so like this FTPS transfer I know is a .NET executable. So let me drag it into a 32-bit dnSpy. And again, I know that this is a 32-bit executable. I'll explain a little bit later how I know that. But pretty much like any other debugging tool, you drag it into appropriate debugger. So let it finish. Okay, and as you can see, FTPS transfer is loaded, so I have to go into it. I know that it's a program. It's not obfuscated, so I can go into main. And as you can see, this is decompiled .NET code. This is, by the way, another reason why writing something in .NET is kind of like out in the open. So unlike native code. Okay, so and then if I want to actually debug it, I can put a breakpoint. I can hit start and give it a second. And as you can see, I can actually step through it, and pretty much like you would do with Visual Studio, with the exception that I do not have any source code. So this is very, very helpful. Now, as you can see, if I go into watch window and let me delete these things. Now, in case you don't have watch window available, which you won't in the beginning, you can go into debug, windows, and watch, and it will open up. And then, for instance, if I want to know what is the value of flag 2, I can just type in here, and I can tell it this is false. So you can literally debug .NET executables without having any source code, and also, which is really nice, you can also modify them. Let's say if you want to apply a patch, you can modify it and recompile it and have like a separate executable that works according to your modifications. So again, this is not a tutorial about dnSpy, but kind of like a quick overview of how you can use it. Okay, so as for other .NET reverse engineering tools, definitely ILSpy is an older kind of like cousin of dnSpy. It doesn't have the same user-friendly UI as dnSpy. That is why I kind of use it less. But in case dnSpy is not capable of helping with your specific needs, yeah, make sure to check ILSpy. Now, D4.dot is an interesting project that should allow you to deobfuscate or unpack a .NET executable. Unfortunately, again, it's been discontinued by the original owner, but so far it seems to be working. Another one that's also kind of interesting is a MegaDumper. This is similar to D4.dot, except that MegaDumper can actually unpack .NET executable from memory when they're running, which is very nice. Now, if you're looking for more reverse engineering tools for .NET, this repository here is actually really helpful. This person here collected all the tools, open source tools that might be handy for reverse engineering .NET. And lastly, for .NET, I'm sure you're aware that Microsoft open sourced .NET framework. So if you go to this link, you have a very handy overview of .NET. And what is very, very interesting and very important for a reverse engineer is that you can actually look into internals of .NET. For instance, if you have well, again, some function that you want to look up, .NET function or .NET class, you can type its name here in the search, and it will give you all the hits for that specific search. But what is also really nice, if you want to know what exactly, for instance, string empty entails, you can click on it. And if you give it a little bit of time, that can actually show you any specific, just a second, any specific code that is part of this specific command. Okay, now guys, you have to like review here on the left and actually see how exactly, where it comes from. So again, I don't have enough time to do it right now, but for instance, with this example, if you want to know like what exactly is this thing, you can just literally click there and review the specific source code for .NET. Again, it's not perfect. It has a lot of information. You kind of know how to navigate it, but because Microsoft open sourced it, you can easily navigate through it and get kind of like the gist of how .NET works. This is very important for reverse engineer. Okay, guys, now further down are mostly tools for native reverse engineering. And the one that is definitely indispensable is the Process Hacker. This is a replacement for Task Manager for Windows. In my view, or for any reverse engineering work, Task Manager is very, very feeble. It doesn't have enough functionality. And Process Hacker is perfect in my view. It definitely beats Process Explorer from sysinternals. And this is one of the best tools that I know at the moment that can retrieve information about processes and all kinds of things running on the system. So I usually put it on the taskbar so I can run it. And it has this kind of like familiar task manager view. And you can just go in and do whatever you need to do, get CPU usage, look up process, look up like what process, loads internally. And there is a lot that goes into it that you literally can spend hours explaining this. So Process Hacker is very indispensable in my view to like retrieve quick information about the process or kill a bunch of processes. For instance, if I don't care about Edge, I can select all of them and I can terminate the whole bunch of them all at once. So this is Process Hacker. Unfortunately, lately it had a few false positives from antivirus vendors, but I don't see anything bad about Process Hacker. Today, I use it everywhere. Another tool which is very helpful is something that came from sysinternals, and this is Process Monitor. To start it, it's very simple. You download and just run the executable. Now, the Process Monitor lets you monitor specific metadata about specific process or all processes on the system. Now, in this case, if I want, for instance, to maintain what my WERSetup is doing on the system, I can start Process Monitor. I can say that process name is WERSetup.exe to include, add, and add filter. And hang on one second. Oh, sorry, I was experimenting early. I added Explorer. Okay, so the filter, again, disregard my Explorer. So let me remove this. So again, the filter is process name is WERSetup and to include. Okay, so when I run my process and close it and stop capturing, as you can see, everything that my WERSetup was doing has been captured here by Process Explorer. And then you can drill down, like for instance, why was it creating file here? You can see that, what it did, how it did. You can see what was happening. You can see the call stack. For reverse engineer, this is a very simple tool to look at what the process is doing, and especially in case of malware, and to kind of quickly see the internals of it without invoking the debugger, because debugger is always, you know, kind of like a low level and kind of like a big hammer. This one is just for like an overview, like a quick overview. And yeah, so this is very, very simple tool. Now, unfortunately, it comes with some steep learning curves, so you need to kind of like understand filters and all that stuff, but once you figure it out, it will be really, really good and indispensable tool for you. So that is Process Monitor. Another thing that is very, very important in reverse engineering work is to be able to see and understand the contents of the file system. Unfortunately, if you go to, let's say, Windows Explorer and go to some location, it hides a lot of stuff from you. Obviously, Windows Explorer is designed for like normal people, and you know, reverse engineers are definitely not normal. So that is why you need some kind of file manager that will show you pretty much everything on the file system. Another downside of the Windows Explorer is that its search is really, really bad, especially when you have to search for the contents of file, or in other words, inside files. This search is just a big no. In my view, I'm using FAR, and this stands for FAR Manager. You can download it from this website. The installation is pretty simple. If you go to downloads and select your operating system, you can get just the full, basically, bunch of files, or get an MSI to install it for you. And once it's running, it looks like a really old Norton Commander, if someone kind of like remembers this. But as you can see, it shows all the files that are hidden in the system, which is really, really nice. Like, let's say Windows, right? And all the folders that normally wouldn't be accessible. So this is definitely, I would say, one plus. And the second thing that is definitely kind of like something that I definitely like about it is that you can open files. Like, for instance, if I go to my desktop and I want to open, let's say, my WERSetup, this file here, is as text, or let's say as a hex, I can do so. Now, commands at the bottom, I mean the numbers at the bottom, it's the F command. So F2, for instance, to change to text, F3 for quit. But yeah, there's a little bit of a learning curve here, but definitely FAR is an important tool in my view. Now, what I also use it for is search. For instance, if you want to search something, you do Alt F7. And let's say if I want to find something that contains word font, and I have to give it permission to search all the files. So as you can see, it finds things pretty quickly, including the contents of files. And then if I want to look into it, I click F3 and then Shift F7. And as you can see, it literally finds all instances of font inside the file. So this search is very handy in my view, and it is much more superior to Windows Explorer. Obviously, FAR has way more features, but this is kind of like my preferred low-level text-based view of the operating system. I'm sorry, of the file system. Okay, next tool, which is very popular, is a really lightweight hex editor. So it's called HXD. And what you can do, as well in most cases, if you drag your binary file into it, the thing that really kind of like the reason why I'm using it is its search. For instance, if let's just say you can obviously search by text, but what is really important is that you can search by sequence of hexadecimal numbers, and it can find it pretty easily. So, and then if you want to, you know, keep going, it just finds it without any problem. And also for applying binary patch, you can just literally just start typing and change change the binary code or hex numbers, hex values inside the PE file or any other file, and then save it. And this is how easy it is to apply patch. I will definitely use this tool for my binary patches that I will show in different videos. At this point, we obviously don't need to save it. So this is hex D, which is very, very popular, and I really like it. Now, the other thing that I usually use for my reverse engineering is Microsoft Visual C++. Now, keep in mind that this is not VS Code. This is full-fledged Visual Studio for C++ compiler. And the reason I use it is that quite often you have to look up symbols or sometimes run a few tests during your reverse engineering work. And Visual Studio still is pretty handy tool for this kind of stuff. Now, the downside of Visual Studio is that this is a pretty large code base. It's pretty large bunch of code. Expect to waste up to 8 or 10 gigabytes of data on your hard disk if you install it. Because of that, I usually install Visual Studio once on my host computer and use it from there. So to download it, I would go to I can just search online, but I personally download C++ version of it, and what you need is a community edition. It comes with a very large installer, and it will take probably from half an hour to even longer to install, depending on your network and computer. But community edition is totally free. You don't have to use anything. The only thing, they might ask you for a Microsoft account to log in, but you can use free Hotmail or Outlook account and it should work. Now keep in mind that these two flavors are actually paid and you don't really need them. So once you download the installer, make sure to unselect everything and install only desktop C++ development tools. And once you're done, it should technically be ready to go. And let me show you real quick what I use it for. Now, when I start Visual Studio, I usually do it on my host. I create a new project, and I usually go for console application, and I usually go for C++. Again, in most cases, you would not have C# or Visual Basic installed. Then I call it test run 01 or anything you want to call it. And when Visual Studio loads up, usually remove pretty much all this C++ stuff and add Windows header, which is important for reverse engineer on Windows. And then if you want to look up symbols, for instance, you can just type them here, go to definition, and here you go. So this is pretty easy and safe way of looking these things up. And again, it depends on your actual reverse engineering requirement, but this is what I usually do. I also run a few tests if I need to see how something compiles into or how something behaves. I always do it in a small test program in Visual Studio. Or lastly, if I want to know, let's say, what is the definition of some function, I just started here. You can right click and go at peak definition or go to definition. And right here, you can see it gives you the declaration of the actual file or the actual WinAPI. And there is a lot of them, as you can imagine. And this kind of helps me because, you know, obviously this is the direct source. This is where those APIs come from. And yeah, so this is how I use Visual Studio. Okay, another tool that is very, very indispensable for any reverse engineer is Detected Easy. Now, this tool is open source. To install it, you have to download the binary and then put it somewhere in the program file, on the program files in your VM, and then create a shortcut. Now, let me demo what this tool is for. Remember, like when I was opening this executable and I wasn't sure how exactly it was built, or when I was actually trying my FTPS transfer and I didn't know, you know, is it a native app or is it a .NET managed app? Because, you know, the difference would tell you which tool you would be using, whether you would be using a .NET types, .NET Spy type tool or native debuggers like these ones. In this case, Detected Easy could tell you the answer. So let's say if I drag my WERSetup, which is a native tool, into it, if you give it a second, it should show you. Now, I'm not sure what's going on. Let me try it again. Yeah, so I'm not sure what was happening, but let me try it again. Technically, if you drag it into the icon, oh, here you go. Well, you see this thing is written with Qt, which makes it very, very slow and very bulky, unfortunately. But it kind of works. So as you can see, I opened my WERSetup into it, and if I look into it, you can see that it was built with C++ compiler. It tells you that this is a native tool, and it also tells you that this is 32-bit. It also tells you that this is a binary signed file, and this kind of like this tidbit of information tells you that you have to use native debuggers. Now, if you take another example, like my FTPS transfer binary, and do the same thing with it, you can tell that this is a .NET library. It also binary signed, but .NET tells you that you have to use a totally different set of tools to reverse engineer it. Because again, if you start using like any of the native debuggers for this kind of tool, they will still run, but it will be very, very difficult and challenging for you to actually, you know, work with .NET code using native debuggers, and also vice versa for the managed tools. So this is how you can kind of tell what binary is built with. Additionally, if you're reverse engineering malware, Detected Easy and similar tools can actually help you to see what kind of packer was used inside and so forth. Okay, another tool which is kind of important for reverse engineer, in this case, is a PE viewer. I used to use another tool which was called PE internals, which was very nice and handy. Unfortunately, the current website of the author shows some weird information, so my guess is that he gave up development. So right now we have to go to something that is still supported, and this is CFF Explorer. Again, it's an open source tool. You can download and install it. In my view, it's really nice in case you want to do a binary patch of an executable. So again, here's its icon. If you drag your file, your binary file, into it, it will show you the PE structure of that file. And for instance, these are the sections inside that PE file. In my use case, what I usually do, I add, for instance, if you want to add a section here, you can do so, and you can call it something, right? And obviously provide all the flags and so forth that you need for the section. But this is kind of like an easy way to modify your PE file without going into like in-depth knowledge of the PE header structure. Okay, so I don't want to save changes. Obviously, CFF Explorer can give you way more information about PE, so it's kind of just, again, quick overview for you. Okay, another tool that is very, very important is my own WERSetup. You can download it from this link. It comes literally as just a single file, and I've been kind of torturing it throughout this demo. So let me show you what it does. So originally, when you start it up, it will have, oh, by the way, one thing, sorry. When you run it, make sure to run it as administrator. And let me revert all of this stuff here. So yeah, I'll redo real quick. So when you run it and start it and run it as administrator, this tool allows you to set up what is known as Windows error reporting. And if you're curious, you can click on the link here and Microsoft will kind of like give you an overview. But in a nutshell, when apps crash on Windows, Microsoft internally can generate a crash dump for those applications, and they have specific kind of like hidden registry settings that can let you specify, or let developers specify which apps and what type of a crash dump and where to save it. Now by default this functionality is not enabled. The tool, the WERSetup, lets you enable or set up this crash reporting. So let me show you how it works. So when you run it as administrator, I usually go to sorry, not that. I usually go into my computer, local disk C, new folder, and I usually call it crash dumps, just to be, kind of like descriptive. Make sure you check setup ACL to allow access for everyone. And then I usually specify full dumps and set the limit to 10. What will happen here is that when you click save, every time something crashes on the system, Microsoft Windows in this case, will place an automatic crash dump of a crashed program into this location. Again, we specified it here. Now, as programs crash, hopefully not a lot, but as they will crash, especially if you develop something, or if you reverse engineer and you change something and it crashes, this is a really good way for you to catch that. Now, let's say if there is 10 crashes generated, like I specified here, the 11th crash would remove or automatically delete the first crash, the oldest one, so that the maximum number of crash files are always 10. Now note that my tool doesn't do the actual crash dumping. It is done by Microsoft Windows. The tool only sets it up. Okay, now to demonstrate how this works, let me go back to my Visual Studio app, and in this case I'll just show you how you can run a simple test and how I use Visual Studio. So let's just create some very simple buggy app with the buggy function. Let's say the function doesn't take any parameters. And, well, actually, you know what if it takes a pointer and then it dereferences it and returns something plus 2 that it got from this int. And let's say we want to call this function and we want to pass a null pointer. So what I'm doing here, I'm creating a controlled crash to kind of show how the crash dumping works in Windows and how you can benefit from it. So really quickly, let me just explain here. Let me just add a little bit. I believe it's control class. Hello, Microsoft. Okay, well, I'm hoping that you can see this. So what I wrote is a very simple function called buggy function that takes a pointer, then dereferences it and returns whatever it reads from the pointer plus 2. Because we will be building it as release or optimized build, we want to make sure that Visual Studio Compiler doesn't inline it. So that's why this little Microsoft specific no inline statement. This basically says that, hey, don't put this thing in here, but instead keep this as a function. Okay, so let's run it. And because we are dereferencing a null pointer, this thing should crash. So just to confirm, let's run it. And sure enough, exception thrown. This is what we wanted. Okay, well, let's simulate a situation when you would take this file and let's say take it to let's say your customer folder. So if we go into your customer system, if you take the executable and also symbols for it, and if we bring it into our test folder. So let's see what happens when I run this file. So in this case, as you can see, Windows error reporting is set up to put all the crash dumps into C crash dumps folder. And let's see what happens if I run it. So the app runs and crashes, and right off the bat, we get our crash dump. Now this is very, very handy. I usually keep this folder open all the time, so in case something crashes, I can see right away that there is a problem. Now, how do you analyze what happened? Now, real quick, if you remember, we installed WinDbg. We can use WinDbg to actually see what happened. So if I double click on the crash log file, right off the bat, you can see that the WinDbg tells us that this is access violation. We don't know exactly what happened because, again, the call stack is not very helpful. And if we click Analyze V, the WinDbg will try to get some information, and we can definitely see that there's a null pointer dereference in our test app buggy function. The reason it can do so and it can see all this information is because we provided this PDB file that actually gives symbols to WinDbg. As you can see, this is very, very handy because with this simple trick, you can definitely, you can immediately tell where the problem comes. Obviously, in this case, this is a somewhat silly example, so it doesn't really give us much. But in this case, if you have a real example of a real crash, that will be a very handy thing to have. Okay, so this is what WERSetup is and how you can quickly analyze crash dumps. Again, this is not the video about them. This is just a small example. Okay, another tool that is one more of my creations is WinAPI Search. It's a free tool. It doesn't need any installation. In my case, I have it installed on my system. Let me show you what it does. Now, WinAPI Search is, well, it does exactly what the name has. It searches Windows functions for specific names in APIs. Now, let me give you an example. Let's say if you wanted to know which Windows functions have create window in their names. Now, this is helpful for research into Windows operating system, and this is also helpful for in case you have to look up certain function and look up which functions are available. So let me give you just a quick and dirty example. Let's say if we search in system32 folder, we search, let's say, for all DLLs, and we'll look for exports, and we'll look for anything that contains create window. If we do search and let it do its thing, we can see that all these functions have create window in them. Obviously, well-known create window X, but then, well, there's also create window in band X, create window indirect, create window station, and so forth. So it's kind of like something that can let you look up how exactly certain functions are called, and so what are specific APIs in which libraries. Like, for instance, you can see that like these functions are exported from user32, but then there are other ones that are exported from other libraries. Additionally, what you can use this tool for is for a search for error codes. Let's say if you have, let's say, error code 5 and you want to know what this is, you can quickly see that it is access denied in like many modules, although not always. So this is kind of like really quick overview of what WinAPI Search is. Additionally, it can also act as a Windows dependency walker software, which has been discontinued, so it has similar functionality. Okay, let's move on to the next one, Spy++. Now, Spy++ comes as a set of tools for Visual Studio, and it's a really old tool, but basically it allows GUI developer to look up information about specific window classes, so and controls themselves. So for instance, you can get styles, class information, the process that owns it, and also, which is kind of handy, you can also see live messages for this specific window. So this is Spy++. Again, it's usually used by GUI for GUI debugging and also for reverse engineering a GUI app. Now, my own version of Spy++ is my WinID. This is a really old tool that I've written a long time ago, and you can download it from my website. And when you run it, the way this thing works is that when you point the mouse cursor at a control or a window, the WinID window itself updates with the information about that controller window. Now, a few things that are really good and what I use it for instance, if you want to know where specific window is coming from, which process. So you can look here where it says image, where I'm pointing with the mouse, and as you can see, CFF Explorer is installed in this location. Also important, you can see window classes, window title, window handle over here, and also window procedure. Now, in case you want to save information about the control or window under the mouse, you hit Shift, and then as you can see over here, you have full text of that specific information saved for you in this window, and then you can save it to the clipboard if you want. Now, this tool is somewhat old and it has a few bugs in it, but I use it for that specific purpose for GUI debugging. Okay, and probably one of the last third-party tools that I want to show here is Resource Hacker. It comes with the installer. It's a free tool, and the good thing is that this tool allows you to modify Win32 resources inside of the app. So just to demonstrate what this is, let me try it with my WERSetup. So if I drag it into Resource Hacker, as you can see, it displays information about the resources. Now, anyone that knows Win32 programming will immediately tell you what these things are. Like, for instance, if I go into version for WERSetup, and then if I actually look up that version in properties, as you can see, the detailed information is what is in the resources. So, and it has all kinds of things, anything from, icons for the app to cursors, all kinds of things that are available here. Now, the reason I would use Resource Hacker is sometimes to modify the behavior of the app without changing the code. Now, just to give you just very simple example, like for instance, if you see in the dialog tree here for WERSetup, you can see that its caption is actually editable. Like for instance, I can say that the caption will be Windows Error Reporting Setup 2. Well, let's say if I want to do that. And then if I compile the script and save, and then close Resource Hacker, as you can see, I got two files over here. One is the original, which basically acts as an original file, and the second one is the modified file. If you look on the title bar here, you see that I literally changed the title of the app without really recompiling it or changing the code. So this is kind of like a quick and dirty way to change something in the app. It doesn't always work, but sometimes it is pretty handy to do. Now, the thing to keep in mind, if you do this kind of thing, this will break the digital signature. So if you go and look in the digital signature and click details, you can see over here it tells you that the digital signature is not valid, when in the original file, if you do the same thing, you can see the signature is valid. So keep this in mind. This is kind of like a small caveat that comes with modifying binaries this way. So let me revert the WERSetup tool, and that is the resource hacker, kind of useful for like a very high level reverse engineering. Okay, and last but not least is the calculator. Now, for any reverse engineering, you might be needing to convert from one encoding or one type of numbers into another. Now, in this case, when you start the calculator, make sure to change it to a programmer. And once it's in the programming mode, you can actually change between hex, decimal, octal, and binary code, which is very helpful. Then you can, for instance, copy it. And, well, let's say if you're working on your reverse engineering project, you can, for instance, say that 1000 hex is 4096 binary, 4096 decimal, or this craziness in binary. So calculator, in this case, the modern, or whatever they call it, UWP calculator, is very, very handy for doing these conversions. Quite often, for instance, when you go into let's say process hacker, as you see, the process ID is a decimal number, right? But then the debugger might actually require it to be in hexadecimal. In that case, you can always do the conversion. So 435 in decimal is 1B3 in hex. So this is kind of like helpful. Okay, the next tool, I think on my list, let me double check, is a good old trusty Notepad. And just as I'm showing here, let's say if I'm reverse engineering something, I usually put my notes here because it's always nice to kind of like get back to them if I'm especially doing something later on, just kind of like to review what I was working on and just to kind of jot down some little notes that would help me later. I usually keep it in the same location, and I usually call it work info, and save all information in there. So yeah, Notepad is really indispensable tool for just like putting notes of your work as you go. And last but not least is a snipping tool. You might be familiar with the snipping tool. It's just basically a tool from Windows 7, I think, that allowed to make screenshots. Well, let's just say you are working with something, and right, so you got something and you got some information here, you highlighted something, and then you feel like, oh, I wish I could remember it later, I might need it. Well, just make a screenshot. The easiest one is when you start the snipping tool, highlight it, and here you go, bam. So if something changes, you have your snapshot. Now the good thing is that you can actually annotate it, and you can save it in a file that you can later use for future reference. It's kind of like an addition to Notepad, to note-taking, because this one is a quick and dirty way to make a screenshot. So this is a snipping tool. Now, unfortunately, Microsoft has discontinued it. I will record a separate blog post where I will actually reverse engineer this tool to make it more user-friendly, but for now, just keep in mind that it's available. I think in Windows 11, they replaced it with the new version, but you can still get it from Windows 10 by just searching snipping tool in a taskbar, in the start menu, and so that then you get your snipping tool. Okay, well guys, I think this is pretty much the end of the overview of all the tools that I'm using for my reverse engineering work. Obviously, I ran kind of fast through it, so again, if you want to go back to a specific tool, I'll put a time code in the description. The last thing that I always do, I create a snapshot of my work, of my VM. After I install everything and make sure that everything works, I usually remove all the temporary files, make sure that everything works the way it's supposed to, and then in case of VMware, I go and create a snapshot. I put the day, for instance, you can do July 24th, 2023, take snapshot, and here you go, bam, it's all done. Just to quickly demonstrate the benefit of snapshots. Now picture the situation that you are working with something and you just completely deleted all your stuff, right? So your operating system is unusable, or you went some wrong way and just totally messed everything up and you wish you could undo it. Well, a snapshot is exactly that. So you highlight the snapshot that you made. By the way, you can do many more, as you can see here. You click go to, wait for it to, revert the files, and just in as little as a few seconds, depending on how fast your hardware is, you get your system back. So as you can see, this is very, very indispensable, not only for reverse engineering, but also for software development. I use it all the time, and it is very, very handy. Okay, guys, so at this point, I think I will conclude my long overview of my reverse engineering tools. Again, thank you for watching, and I will see you next time.